for example. Today I will talk a little bit about the other side of web application security, not what is going on in the web application itself, but what is going on the PC of the user accessing a web application, in particular on a specific part within the browser. But why I'm doing that? My claim is that today web browsers are becoming as important as operating systems became 2 decades ago with respect to the security requirements that we have. And they're becoming not only like operating systems, popping up these error messages like, please reboot. That's actually an actual error message of Chrome. Please shut down Chrome and restart, so to speak. But more like what people are doing in browsers. Like they are playing games. There's a whole Adobe suite with a lot of applications that a couple of years ago we wouldn't have imagined to run in the web browser. I recall when CorelDRAW was tried to be ported to the web browser it was actually before 2000. It was terribly slow as a Java applet. Nowadays, even Photoshop runs in your web browser if you want to have it. Then, of course, we are all reading, or most of us are reading our emails in the web browser in one way or the other. That's already security critical. We don't want to have our emails published to everybody. We are doing e-banking, but not only as private citizens, we are using web browsers more and more for security critical tasks. Also, companies are doing it more and more. That's a screenshot of an SAP system. Most transactions in enterprises are at some point in time handled by an SAP systems. Also there, we see the trend to move more and more functionality into the web browser. So we should be able to expect from a web browser similar security guarantees as from an operating system. So let's have a look. There's a hell lot of work being done in protecting web users, like what we guess most likely we'll hear in one of the later talks, same origin policy, HTTPS only for cookie declarations, content security policy. That's already pretty much done, protecting web users in the context of a specific web application. So web application providers are doing a lot to make it hard to attack their users. Web browser vendors are doing the same. The major browser vendors are heavily invested in developing their web browser securely. We are seeing more and more approaches where tabs are containerized so that one tab in a web browser cannot influence the other one, makes them more reliable, more stable, but also more secure. JavaScript is being run in containers in different contexts so that it cannot affect other parts of your code. So there's a lot being done to make the major web browsers the trustworthy piece of software. And I'm not blaming those vendors. They're doing a tremendously good job. So really a good basis. But then we start to extend that basis with something called extensions. Some people call it add-ons. That was the old name for Firefox. Small pieces of software that we install within a web browser to extend the functionality. And that's no longer the secured gate. Extensions can be very powerful. And then we at the 3-year-old starting to try to tear down the security walls that we built up in the web browser from within. We no longer have the external attacker that runs, that needs to attack our computer we are running on or the web application. We are actually installing a piece of software into our web browser, and that piece of software can start to reduce the security guarantees of our extension of our web browser. And that's what I'm looking into in the next couple of minutes. I'm always fearing that one of my first semester students is writing those extensions. That's my threat assessment. So what are extensions from a user perspective? I'm taking here the Chrome example because they were the first one implementing a novel standard for web extensions, which is now also implemented by all major browser vendors. And for Firefox, we just made the switch a couple of weeks ago. That was the latest versions. The old add-on model is no longer working, and we are working in the same world as the Chrome extensions. Chrome, or Google says in the documentation, extensions are small software programs with a limited to no user interface. And then we see something like that in the Chrome store. 400 megabytes in size. And it's a game, I would say, that's a rather sophisticated user interface. It's a full application. And And there are much more complex applications in the store as well. So they are not necessarily small, they might be complex and have very sophisticated user interfaces. What can extensions do in principle? They are running in your browser, they can access any information that your web browser accesses, which means they can also read and modify any web request your browser makes. And as it's running in the browser, it accesses the data before it gets encrypted with respect to transport encryption. So having that nice green encryption, everything is secure icon in your URL bar doesn't help. An extension can still access that data before it gets encrypted when it's sent to the server, or after it's decrypted when it's sent from the server to the client. Moreover, it can modify not only the content part of the web request, but also all header information, and to my surprise, also security relevant headers like CSP policies. So you can write an extension which removes all CSP policy declarations in the web requests. Nice feature. Same for same origin policy. Course can also be disabled. And of course, you have the parts that user usually want, adding additional buttons to your browser, making nice background images, or enhancing the functionality of your web browser in the context of a specific website. Removing features of a website like advertisement, or adding new features that are not provided by the website, shortcuts, and so on. So really useful. They are offered in a Chrome store, or Firefox, Safari have similar stores. Let's do a small experiment and look for a calculator. That should be a pretty easy extension, shouldn't it? And it shouldn't require a lot of security permissions, a lot of rights, because I mean, it's adding two numbers. You find the nice long list of calculators actually, and selecting one, yep, looks nice, let's install it. Oh, that dialog box that Chrome shows here tells me the extension that you just want to install can read and change all your data on websites you visit. In that specific term, that means that extension is asking you, am I allowed to modify everything that you do on the web? Is that fine for you? And most people click OK, add extension. So there's a potential security risk in there. It's not only a potential one. This is a real case which, to my surprise, only or mostly made it only into the German newspapers. That was an extension, Web of Trust, which was actually advertised as making web browsing more secure. The idea behind that extension was we have a database with websites that distribute malware or have other security critical content on it. And before you browse to that website, we check if that URL is in our database. And if yes, we warn you that you do not by accident go to visit such websites. What they did is not, and for that functionality, of course, they need to have that permission that they can read what websites you are visiting. But of course, it would have been sufficient to read the domain name of the website you are visiting. Actually, they copied your whole URL data, including all parameters attached to it. And then that company started to sell that data for marketing purposes. A German news magazine, they didn't even bought data from them. They just called them and asked, we are a company that wants to do data analytics. We would like to have a test data set from you to see how good the quality of the data is. So only with the data they got for free, they were able to de-anonymize the data, because if you have all the URL strings and you have the session IDs, you visit web pages like Facebook, where your real name might be in the URL, so you can rather easily de-anonymize it. They showed how they did it. Their whole big data analysis set was more or less crap and SED. Not very sophisticated, I would say, for somebody who has some basic Unix knowledge. And they found interesting stuff in there. Text declarations of German members of parliament. In Germany, text declarations are considered as something very privacy critical, and you don't share your text data with other people besides the tax authorities. International search warrant information. So the German police using Google Translate for translating a search warrant before contacting the British colleagues. Also not data that you want to transmit somewhere else, and most likely also violates a number of data privacy laws. So it is a real issue. Another example is more the money-making type of example that was heavily used in India. An extension that replaced the support phone numbers of computer companies with very expensive numbers. I haven't checked it, but I assume that they just forwarded the calls to the original call center. So the users calling those numbers got actually the service they wanted without the bad guys investing a lot in infrastructure. And while maybe the original call center is charging you something like 50 pence a minute, they charged £5, and the difference was their revenue margin. That looks like a pretty good business model. Not necessarily invading your privacy or your security, but it goes to your bank account. Also not very nice. So it is a threat. Yeah, how do people actually install those extensions? Because, I mean, I'm installing an extension because I want a certain functionality. Extensions are rated in the store. I have information about how many users are installing them. Most likely, if I have two extensions providing a similar functionality, I would choose the one with much more users that are much more popular. So you need some ways for forcing people to install extensions. One way actually is you visit a website and such a dialog box pops up. To continue with that website, you have to install the extension. You have to do it. It doesn't matter if you click OK or cancel. And now assume that that website is offering something that at the moment you really want to look at. So that's one way how people are actually forced into installing malicious extensions. So let's have a quick look into what extensions are from a developer perspective. As said, they run in your web browser. They are more or less governed by core web security measurements like CSP, like content security policy, plus a permission model, like the permission we have seen. They might also ask for permission for accessing your microphone or your camera. A very simple, let's not say simple, a very straightforward permission model, similar to what we've seen on earlier versions of Android. And they are also now moving to more complex ones in a dynamic permission model. So maybe doing the same evolution the permission model on Android had. The core thing of an extension is the content script, which is the part that the extension actually executes. We are seeing here in that content script declaration in the lower part of that piece of JavaScript on the right-hand side, already something like matches all URLs. So that extension wants to execute the JavaScript stored in the content script file for all URLs that you are visiting. When you are writing an extension that only should interact with Facebook, you would hopefully limit that to Facebook as a domain name. And the background script is a piece of JavaScript which is injected into the web page that you visit and is executed in the context of that web page. The background scripts have a two-dimensional permission system. I mixed it up. The content script is injected in the websites. The background scripts it's mixed up on that slide, sorry. One uses these two-dimensional permission systems where you have permissions like accessing the camera as well as on which websites you want to do it. The other one is either injected or not, depending on the domain name. So you can modify a lot. So let's have a look at a couple of real-world examples. So first, looking at the Chrome store. Chrome extensions are categorized. So you have something like productivity apps. There are, for example, the extensions included that improve the offline usability of Google apps, like the Google Text Editor or the Google Spreadsheet. There's fun and gaming, communication, accessibility. Web development is an own category. And we see that most of those extensions claim to be in the productivity app, so something for business users doing something serious. But quite a number are also in the gaming and fun category or communication and accessibility. And then the numbers go down. In the Chrome store, there are not only extensions offered, there are also simpler things offered like themes, which is the theming of your web browser. We haven't had a look at them in more detail. There are apps that's more Chrome OS applications, though those are technically speaking surprisingly also simpler as extensions. More like encapsulated web pages that you can install on your Chromebook and you get an icon on the desktop, so to speak. As well as a couple of very specific ones offered by Google, which I personally haven't yet understood what they are doing. They somehow work together with the Google Apps offerings. We are looking at that big pile of actual extensions that most likely in the future would also run on Firefox, or hopefully with as little modifications as possible, also run on Firefox. Where do I get those numbers from? What we are doing is we have an extension crawler, a piece of software that runs every night and checks nearly all extensions in the Chrome store. I cannot technically claim that we are crawling all of them, but I'm pretty sure we are not missing a lot of them. And if there's an update to the extension, we obtain the actual source code of that extension from the Chrome store. And for all the extensions, regardless if they are updated or not, we take a copy of the metadata being available, like the description, the current number of active users or downloads, who is the author of that extension, version number, publication date, and the like. That gives us already that kind of static data that I showed on the large page, last slide, and I will show a couple of additional statistics on the next slide as well. And then we have also a framework where I can instrument those extensions. So we are modifying the JavaScript code automatically. So if that extension gets executed, it logs additional information. Like, for example, which data is sent out to a third-party service from that extension, which part of the browser script JavaScript code loaded from the website is accessed by that extension, or does this extension access your local file system or other local resources? Depending on the type of security analysis that we want to do, we configure that extension differently. And then we have a setup where we can install that instrumented extension into a freshly installed version of Chrome. So no other extensions, no other configuration that might block things or harm that setup, and run that in either in an interactive session, so if you want to manually inspect an extension, or using an automation setup, Selenium, that many web developers most likely will know, to automatically then access a couple of websites, interact with them. How we interact with those websites, we script that also specific to the type of analysis that we want to do. So one test, for example, could be checking if websites change the behavior of YouTube. In that case, we would do a setup, instrument all the 80,000 extensions that we have, in each of them individually let access them YouTube, do a couple of interactions, like searching for cat videos. I guess YouTube now has a big pile of log files from us, searching for cat videos and doing an automatic cat video watching daemon. But that's the fun that you have if you have a high performance cluster from the university where you can just use the resources as you like. That's nice. Overall, the extensions are 3 terabytes in size. Fun facts aside, from those 3 terabytes, 23 gigabytes are JavaScript. And there are at least 3 extensions with more than 100 megabytes of pure JavaScript files. I haven't yet looked into that pile of JavaScript they ship, what they're actually doing. But that's the extreme side in terms of being large. Let's have a quick look at the popularity of the extensions. What we see here, most important takeaway from that slide is there are less than 100 extensions which really have high download numbers. So while there are many, many, many extensions in the store, let's say only very few extensions have very high download numbers. So here, more than 1 million is less than 1%, more than 100,000 downloads is something like 25%, and more than half of the extension have less than 100 users. That's not a lot. So again, we here have a store with a lot of offerings, but only a few of them are actually really widely used. Extensions can be big. That's the JavaScript lines of code with some crude measurements of lines of code. So of course, if it's an obfuscated script or a minified script, then it's only one line of code. That's a little bit misleading. We all know that lines of code is not a good measurement, but it gives some idea. We also see again, most of the extensions are actually small, as Google claimed at the beginning, but we have those outliers. Similarly in size, most of them are more in the size range below 1 megabyte, but there are also the others. And there are a couple of extensions that are actually large, and it makes sense that they are large. I've seen one extension, for example, that is a training program for doctors in third world countries. And I guess the idea there is you can install that extension on your Chromebook easily without having a lot of computing skills when you have a good internet connection, and then have all the data that you need for treating patients offline when your internet connection is not that stable or you don't have an internet connection at all. I can understand that business model. So not all extensions that are large are by definition bad. Don't want to say that. But I'm still wondering what you can do with 100 megabytes of JavaScript files. What are they doing? Or what do you need to do if you want to do something bad with them? If you want to observe the browsing behavior, you only need to ask for permissions like the tab permission or the all URL permission, and inject the contents or inject the content script on all sites that you visit. That's the type of dialog box that you see. That's exactly the one that we've seen with the calculator. And I didn't need to search long for a calculator asking for that permission, because roughly 60% of all the extensions that we analyzed request a combination of permissions that gives you those rights, the ability to observe your browsing behavior in real time. So more than every second extension asks for that. And I did a little bit more detailed analysis. Surprisingly, calculators are one of those categories that particularly often request that permission. And interestingly enough, those calculators that are used by many people request much more permissions than those extensions that request, those calculators that request fewer permissions. I don't have a scientific explanation for that, only a personal one. If you buy a Chromebook, there is no calculator application pre-installed on that Chromebook. And I just assume that you want to add two numbers. You need to have a piece of software for that. So you go into the Chrome store, search for calculators, and you don't, normal people, I mean, me neither, would consider a calculator extension as something security critical. You don't think long about installing a calculator app. You assume it's something small and harmless. So you just take the first one being shown in the Chrome store. While, for example, we did a similar analysis for ad blockers, which by definition have to request a very powerful set of permissions, but also there are a couple of ad blockers that ask for ridiculous permissions. And interestingly enough, they are not installed by users. So it seems to be that an ad blocker is something people install after thinking much more about what they actually install, and a calculator is more something that you install spontaneously. That's my completely non-scientific personal assumption on that behavior. That's another nice combination of permissions that you can ask for. The all URL and web request permission. That's, interestingly enough, it shows exactly the same high-level description in the Chrome store, but this is much more powerful. So that's maybe something that could be improved in the user interface, making the security assessment more easy to grasp and more user-friendly. The same high-level message is being shown, but actually it allows you to really modify each and every web request being received or sent. And that includes disabling content security policy or same origin policy. So if we then have an attacker that is able to force you to install an extension, doing something like that, and you access a website that tries to protect its users with a content security policy, the content security policy is void, and suddenly the attacker is much more powerful. So combined attacks, being a standard web attacker plus having a prepared Chrome extension available, really results in a very powerful attacker model. and it breaks the security guarantees that we have in modern web browsers. Luckily, only roughly 10% of the extensions that we analyzed request that permission set. But still, too many for my personal taste, because I actually can only see web development extensions really needing that kind of power on a regular basis. I mean, if you're a web developer or a security tester, then of course it makes sense to have an extension that explicitly allows you to disable a content security policy easily, or it might be at least more convenient than using a proxy in between. And in particular, it eliminates the need for setting up an SSL proxy. So again, there is some good reason for having extensions requesting that, but I would assume that not 9% of the extensions are all for web developers, and they are not. Again, it's pretty easy. This is the whole source code or the whole process, more or less, for creating an extension that steals all session cookies on all websites that you visit and transports them to evil.com. So it's really not a lot of JavaScript that you need to know. And more luckily, as the extensions are distributed in source code form, if you want to hide that in an extension, and of course you need to have some attractive business model of that extension itself that people install it, you just download whatever extension that does something people really desire from the Chrome store, insert that little piece of JavaScript, trick the configuration a little bit, and resubmit it to Google. And hope that people install your extension instead of the original one. And that happens actually quite a lot. It's still possible even to do that without changing the name of the extension, because Google only checks an internal hash value, or an internal identifier, not a hash, an identifier of the extension for uniqueness. Otherwise, you trick the name a little bit like we know it from domain names. Not very difficult either. Now I will show 3 different scenarios that we analyzed a little bit more in detail. This is a very recent one. Was interesting to learn a little bit of how Google reacts, what is being publicized in the media. So end of September, there was a big news release, at least in the English-speaking world, about Chrome extensions that mine Monero in the background. If you never heard about Monero, think Bitcoin. It's a cryptocurrency. It's the same as Bitcoin, technically a little bit different, but that doesn't matter at all. The idea is if I can trick users into installing an extension that mines cryptocurrency in the background, for my gain, I'm becoming rich. I have a large distributed network of people mining Bitcoin for me. That was made public on September 19th. In our regular download of extensions, we only have a version of that extension which does not mine Bitcoin, and then it was removed from the store, which means Google removed that extension after being notified from the store in less than 20 hours, roughly. So very, very quickly. So most likely not many of the users of that extensions were actually affected because Google reacted so quickly. And then I thought, we have that data available, checking if the extensions are mining Monero, if you have the source code, isn't that difficult. And I have that unused large computing facility of the university, so why not run a big grep over all the extensions and check if other people are doing that as well. And 2 days after the press release, I found at least 16 other extensions also mining Monero. The interesting meta-analysis then was they were all published in the store after that press release. So most likely that press release motivated people to say, hey, if that guy can make money with it, I want to do it as well. The other interesting observation was most of those 16 extensions were not fresh extensions, but extensions with an already existing user base which more or less looked unmaintained. So the last update was more than a year ago, which is pretty long for an extension, which led me to the assumption that most likely somebody hijacked the Google account of those developers and just waited for a good moment for making money with it. Interestingly, the people that inserted the Monero scripts forgot to add the necessary permissions for mining Monero in a couple of extensions, so they needed to ship up an update, which they actually did mostly within a day, for I think 8 out of the 16. And the other surprising aspect was I then also looked to which wallets are those extension mining. And there was a correlation between the original authors of the extension and the Bitcoin wallet. I don't know why this has been done. That kind of would would be a counter argument to my reasoning that it's one guy that hijacked a couple of accounts, but maybe he wanted to hide his traces that way. I don't know. But they're really supporting those extensions. And yeah, we notified Google about them, and they were also then successfully removed from the store, because that's at least a violation of the terms of services. There are also a couple of extensions which mine Bitcoin on purpose, which clearly state we are mining Bitcoin, for example, for the good of a charity. And then, of course, if you install it, there's nothing bad with it. But if you do that in the background and use the power of your users, then please inform them at least. Another way of monetizing apps that we've seen is apps that change. So Amazon has an affiliate program where if you add some tag to the link to an Amazon product and somebody accesses Amazon over that link and buys that product, you get a little bit of the revenue. And that's, of course, also a way of making money with extensions. And that's not that easy to detect because they're usually hiding their traces. It's only a small piece that you need to add. It's more like, yeah, you need to replace any links to Amazon and add some parameter to the URL. So that's something which is not easily to check statically. So we did that with a dynamic analysis, again, where we run all the extensions on that large cluster. And we checked if they are adding the links on websites like amazon.co.uk, which is the British version of Amazon, British entry point to Amazon, the international one, the com domain, and the Italian one. And we also there found quite a number of extensions which did that. Here we found also a larger amount which actually declared in their terms and services that they are doing that, again, either for officially informing the users, we are doing that to finance the development of the extensions, and hopefully you are happy with it, or because, again, with the idea of the revenue going to a charity. But the large number did not declare it, and again, not necessarily security risk, at least I cannot assess that because I do not know what information an Amazon affiliate partner actually gets about the people that buy something by Amazon via the links they are generating. I assume that this would only be used within Amazon. I still consider that a privacy issue. I mean, at least Amazon knows that you did access their website coming from somebody that uses that tag. And that could be, of course, an organization you don't want to associate with yourself with. And maybe then suddenly strange things pop up in your Amazon suggest list, what you want to buy next. Let's say if that was a racist organization or so, you might see some fancy books also in the suggest list. So shouldn't be done either. And it's definitely a violation of the terms of services of the Amazon affiliate program. More security severe is actually something which we spotted as well in the dynamic analysis. These are extensions which are misusing Google Analytics or other well-known analytics JavaScript libraries. So usually when you use those libraries like Google Analytics, if you add that to your website, you only get information about the behavior of the user on your website. You're collecting telemetry data to improve your website, which buttons are clicked or something like that. That's a reasonable use case. You can also add those analytics scripts to your extension. Again, if you do it as Google is suggesting it, to learn what is the user doing with your extension. Again, which buttons are clicked, which features are used often. Makes sense to collect that data if you want to improve your extension. What we've seen is extensions that actually inject those analytics scripts in each website that you visit. And then suddenly that extension author learns your behavior on all websites that you visit, regardless if that domain is owned by him or her, or if you're doing something with actively with this extension or not. It's really collecting on large scale your complete browsing behavior. Again, as in the example with the German TV station, including all parameters attached to the URL, which means information about Google Docs that you're currently editing, Google Translate, Facebook content. Whenever something is attached to the URL, it will be transmitted, and it will be nicely translated to the servers of the analytics engine, for example, Google Analytics, which makes it hard to detect it from the outside because most websites are already including Google Analytics. And if there are 2 requests to Google Analytics instead of 1, nearly nobody notices. So that's really something where instrumenting the actual source code of the extension comes handy because we know exactly that this request was initiated by that extension. And we've even seen extensions adding unique identifiers to the request so that it really can identify you over all those websites, which is not nicely shown in the Google Analytics website then if you log into your webmaster console, but I assume they have some scripts which then scrap that data from the Google Analytics website and analyze them locally. So that's something which I consider as really a big issue in terms of privacy violation. Luckily, we only detected 18 extensions, and we are only talking about 250,000 of users, which, given the total number of users of Chrome, is not that large. So I don't want to hype it too much, but from a technical perspective, it's definitely an interesting attack. Outlook. How can we map web browsing making great again? Great in terms of increasing the security, integrity, privacy of the people actually using a web browser. So how can we ensure that actually the content that you look at the website at is not modified or only modified when you want to have it modified? Of course, I cannot browse the web without an ad blocker. So I want the web blocker to modify certain content on websites, but not all of them. And what modifying content means might also be very context sensitive. If I have white text on white background, it's invisible to me, but of course for the computer it's still there. And if this is my bank statement or a wire transfer order, then a couple of zeros here and there might make a big difference. To my bank account and to the computer, if I can't see them, it's not good for me. Data transmitted, confidentiality, privacy, we already discussed. On the long term, people, not only we in general, are working on sandboxing of extensions. There are works considering different permission models. We've seen the presentation is not nice. It's actually pretty hard for developers for specifying the minimal set of permissions. That might be another reason why they overly specify them and just in case ask for too many permissions. Introducing of a dynamic permission model that's actually now becoming much more common nowadays. And also better analysis tools. So that's also a part where we are working on. On the short term, if you are using extensions and you would like to minimize the risk falling in these kind of traps, in principle 2 different models that the security community is discussing in general with software and software that might be taken over from bad guys is frequent updates. So you have the automated updates, you always get the new version. But that also means that if somebody is hijacking that extension, you suddenly get that Bitcoining mining version pushed automatically on your computer. Or you have a strict governance. You say exactly these are the 5 extensions that I allow my users to install if you're on a corporate setup. And the update is being pushed via some centralized update mechanism that I have under control. So in theory, I can inspect whatever is installed on the computer first before it's installed. In reality, we would like to have something in between, of course, and that might be an approach with whitelisting certain extensions where you believe that it's more unlikely that the Google account gets hijacked because the organization behind is very careful, or Google offers them additional protection measures. So, for example, the extensions offered directly by Google or other large companies most likely are less likely to get hijacked compared to the extension provided by a hobby programmer, which doesn't have a lot of time for securing the whole development setup. So as a general guideline, then check the vendor of your extensions when you're installing something. If there's a Facebook extension that are claiming originating from Facebook, but the author tag says something different, that's suspicious. Check the permissions. In particular, active domains is something which is heavily overspecified. So if you're installing an extension for Facebook, most likely it needs only to interact with Facebook. If you're installing a calculator that gives you revenue calculations from Amazon or eBay, you might want to have it to access to eBay or Amazon, but it doesn't need to access other websites. It's a little bit tedious. You have to do that manually because only you know what you expect from the extension. But it's advisable. If you're a little bit more security cautious, then maybe browser profiles are an easy way of separating a browser instance which you are using for more security critical tasks like e-banking, because those extensions are installed separately in each and every browser profile, and all modern browsers easily allow to switch profiles. And yeah, be aware of the risk when you're installing extensions. Maybe you don't want to test each and every strange extension in your main web browser. Again, use a dedicated test profile or a temporary profile for that. Thanks. With that, I'm happy to answer questions. Still have 5 minutes roundabout.
First of all, thank you, Achim. Questions?
Hello, thank you for the talk. I have a question about the extensions. Do you know, imagine to have more than one extension, which one is the order of the execution of the extension? Because you can kind of think of extension which is forbidding all this changing of the headers, for example, kind of security exception, whatever security extension is. So if you have 2 extensions on your browser, which one is executed, in which order, or can you kind of choose it?
That's a question I was asking myself. If those extensions are injecting JavaScript in the same context, I assume it's based on the order of the internal ID, because the browser is distinguishing those extensions by their ID, and if you look how they are installed on the system, for each extension you have a directory with the ID name, and I assume it's just in the order those IDs are sorted, but I'm not sure. But just to complete that, if you have one extension that modifies the header data, it of course hooks to the event for the web requests. And then most likely it is able to modify them before other extensions get them. The problem would be if 2 extensions want to modify the web request, then you have a race condition.
Thanks for your presentation. I always wonder how reliable the pop-up system with the warning messages is. In other words, did you ever see an extension not warning you for accessing some data, but in fact it did?
No, but we haven't explicitly looked into that, but I assume that that part is pretty well done. The problem at the moment is more that the extension are just asking for all the permissions. So I haven't looked into circumventing a permission system as such.
Hi, can 2 extensions communicate?
Yes.
So you can have a composite permission.
You can have exchange between 2 permissions, and of course you can have 2 extensions that both request a small set of extensions, and the combination is problematic. That's, if you want to plan an advanced attack, that's possible as well.
Yeah, we are using Chrome on the corporate level as well. Is it possible to block all those extensions or whitelist extensions on the corporate level from an enterprise perspective?
Should be possible. I can't give a definite answer for all operating systems. Yeah. For example, on Debian, it's the way that in the default installation, only extensions are activated that are distributed via the Debian software repository, which some people consider painful, others consider it a security advancement. I would assume that, for example, the Windows corporate administrative controls allow you to control that as well.
Of course, he's available during the break as well. Thank you, Achim.
Thanks.